IPC is the organization that serves the industry in a variety of ways. And today's career luncheon panel will be a fun opportunity for you to learn from these amazing panelists on the stage. But I would like to introduce to you the CEO and President, Dr. John Mitchell, who runs the ship for IPC. He will be moderating this panel for us, and I am definitely just going to hand over to him. And then he will do a Q&A afterwards. So if you want to engage and ask questions, be sure that you put your mask on.
There's no if you want to engage. I'll be coming to your tables. We're going to engage. It's going to be a good time. All right. Are we doing introduction slides to start with? All right. Let's start with our first panelist so you can get to know them. First, we have Matt Kelly, who is IPC's chief technologist, formerly from IBM, designing the world's most complex microprocessors, right? Semiconductors. Isn't that what IBM did or does? I do so. I think they do. All right, very good. You want to say a quick word to everybody, so we can make sure the mic works for you?
Hi everyone. Hopefully you're enjoying your lunch. If there's questions, really what I'm here to do is to try to share some experiences. Looking forward to answering questions.
Yeah. After the introductions, I'll kind of do that for everybody. But next we have Christina Rutherford from, where are you from? Can't see it, it's too much.
Aerospace.
Where? Honeywell? Honeywell Aerospace, yes. Oh, no, just well, actually, let's do this the other way. Go back to now. Sorry about this for you guys online. This is the reason we need to get going. There are actually people online also participating. They're like, for those of you online, welcome. We also hope you're enjoying your food, if you have some. Actually, it's probably, for most of those across the country, it's well past their lunch. Matt, can you just share what you currently do?
Sure, yeah. Hi everyone, my name is Matt Kelly. I'm IPC's chief technologist. My job, very simply, is to make sure that IPC is working on the right stuff at all times. As you can tell, there's lots and lots of things going on in the industry. We're trying to make sure that we're focused on what you, our members, really want and need from IPC.
Thank you. Christina, same company you work for is Honeywell Aerospace, and what do you do there?
So I am a materials engineer down at our Clearwater, Florida facility for space and defense systems. And mostly what I work on is supplier development and developing manufacturing processes with our suppliers and making sure that they're done correctly and to the standards.
Very good. Next we have Chance. Is it Tinner or Tyner? Tyner. Chance Tyner from TTM. TTM is our sponsor of today's panel, so we're grateful for Chance pulling out his pocketbook and paying for this person.
You're very welcome. Thank you all for having me. Proud to support STEM education and advancing careers. Hopefully, you all will be applying for our TTM Technologies intern program soon. To give you an overview of what I do, I'm a mechanical engineer at TTM Technologies, mainly focusing on supporting drill and wrap operations as well as testing. Thank you very much.
Yeah, and he's located here in San Diego.
Right here, San Diego, Florida.
Yeah, so he was serious about those opportunities. They're right here.
Yes, sir. Yeah.
All right, next we have Avi, and how do I say your last name, Avi?
Yankovic.
Yankovic. Yeah, I would never guess that how it's spelled. I'm so bad. Very good. Avi Yankovic. So if you're asking a question about if you'd like to direct your question. Avi, oh, sorry. Avi is from Nano Dimension. Please share what you do with the.
So I'm senior applications engineer in Nano Dimension, which is an Israeli-based startup, and we're now growing like crazy. What I do on a day-to-day basis is just take ideas from my customers or my customers and really help them material these ideas using 3D printing, which is all the new revolution nowadays.
Very good, thank you, Avi. And finally on our panel we have Jason Fullerton from CAES.
Yes, that's what CASE.
CASE. All right, so it's not CAS at all, it's CASE. Tell us what you do.
I'm a principal manufacturing engineer at our facility in Lansdale, Pennsylvania. My primary responsibility and expertise is in the soldering and printed circuit boards, so surface mount technology, wave solder. I help us get soldering today over the experience earlier. We also have a site here in San Diego, so when you guys are looking at your career here for college, I'm sure you can listen on as well.
Very good, very good. Thank you all. So let me start, and since you've got the mic already, Jason, let's start with you. We'll go the other way down. Share a little bit about how you got in like 2 minutes from high school, your thoughts on high school, since most of our audience is high school audience, to where you are today. Did you plan on that? Did you sit there in high school? Oh, I know I want to be a materials engineer.
So I went to college at GMI Engineering Management Institute in Michigan, now known as Kennedy University. So I have an undergraduate degree in manufacturing engineering. A big part of that program there, and something I recommend highly for everybody when you go to colleges, is a little bit of school that provides you opportunity for career experience while you're an undergraduate. So GMI focused pretty heavily on the co-op program. And when I went to go find a sponsor for my co-op experiences, I had no idea what kind of industry I wanted to be into. The career department had me send resumes to alumni of our school that were currently working in the industry, trying to find me a place where I could fit in and get a co-op sponsorship. And it happened to be an electronics factory in Philadelphia. So I tell people that I didn't really choose electronics. Electronics chose me. But now it's all I know. I'm kind of good at it, so it's what I do for a living now. It's very challenging. It's an interesting industry. It's always evolving. When I started my career, we were making, removal circuit boards on wave solder with large spacing and low capabilities. And now we're making microelectronics with very small spacing and very high power. So over the 25 years I've been in this career, it's gone from really one kind of industry to another. And in the next 20, I fully expect it to be a wholly different industry than it is today.
Good, thank you. Avi, same question. Did you plan to get where you're at? Was this a purposeful decision, or did you take a winding path?
Ever since I was a child, I knew two things. I wanted to build spaceships and I wanted to build robots. And that's kind of a general idea. I didn't know what to take it. When I was 16, in high school, I started playing guitar, and I figured that these effects that make the guitar sound good is actually made out of electronics. So this is what I chose to do in high school. Later on, I was recruited to the IPC, so transport. I was doing a lot of electronics there. This is where I got most of my experience, most of my co-experience. I had great mentors, great chief engineer. So I really used this opportunity of 3 years to not only make sergeant and make rank, but to also learn a lot about what I was interested in, which was robots. Not exactly uniform robots, but any machine that will do the job better than me. So I got that experience from high school and from the Army and from the job market. And I'm kind of I guess, a new type of manufacturing engineer, because career-wise, I was born into 3D printing. I have 5 3D printers at home. I got 2 more in the lab at the Florida facility. And I just love 3D printers, and I think it's just wonderful that you can summon something, and it's great to take part of that. So it's all experience based, and I try every day to enhance my experience. This really my experience is priceless and also super cheap nowadays. It wasn't so cheap 5 years ago, but now it's super cheap. It's super available everywhere on the internet. So go grab it if you're curious about it, and sky's the limit.
Very good. Chance.
Yeah, thank you. So I went to San Diego State University, USDSU, sweaters around there, which I love. Coming out of college, going into COVID, job market was obviously quite tough. One thing that's nice about working at a PCB shop makes components to the aerospace and defense industry is the aerospace and defense industry remained quite strong during COVID. So they wanted to bring me in, and I'm training up on how exactly printed circuit boards works and what goes into making them. That's really what drove me to TPM, is their drive to mentor young engineers and young people, get them technical skills so they can be useful.
Good. Christina.
So when I was in high school, I was dead convinced that I was going to work for NASA. Didn't work out. I'm at Honeywell. That's okay though.
Close.
It is close. So I wanted to be in chemistry, so I was like, I'm going to do chemistry. And then as soon as I got my degree, I was like, no, I don't want to go get a PhD right now, but that kind of means I have to pick something. And I knew a manager that was like, you know what, try materials engineering. Like, just try it, see what happens. And that was how I also fell into engineering, where they're like, you'll be good at it, just try it. I was like 5 years ago now. And been so much fun, you know, and like I didn't make it to NASA like I thought I was going to, but I say hi to NASA while I'm here every week. And it's so much fun to get to see how the industry evolves and how absolutely every possible thing you can think of goes into electronics somehow, some way.
Good. And Matt?
Yeah, so I'm gonna officially date myself. Because I don't feel like.
Is your wife okay with that?
Yeah.
Oh, that's the other kind of date, sorry.
See, I didn't even get that joke. So I have a slightly different, different story on this. So, I went to high school in the early 90s. And if you can believe it or not, there were no personal computers in mass that you have today. I mean, my 10-year-old had more computing power at her fingertips than I saw until I was in third year university. Not too long ago. The earliest story I can really remember is when I was a kid. I can't remember the name of the show now, but they still have them today. There are those how things work or how things are made, those shows. And I remember things like, how is a pencil made? How do you get the lead in the middle of the pencil? How do you make whatever? And this was my favorite show. So I actually believe, thinking back now, that's actually what really got me interested in how things are made. And the reason why I'm an engineer myself today. Moving forward a little bit into high school, that's when the computer really started to come out, and it was just super interesting, right? Forgot quickly about some of the detail there and decided to study chemical engineering. Similar to you, I realized I was headed to the oil patch in Western Canada, and you know, rightly or wrongly, just didn't want to do that. So I too pivoted and learned that there's a lot of chemistry, a lot of materials in computing systems. And here I am today, 20 years later. So that's my story.
And I'll give you just a short background, similar for me. I'm all over the map. So I think I'm the oldest guy here. I'm not used to that. Wow. So I started off and I wanted to be a computer programmer. And then my dad said, why would you want to be a computer programmer? That's just a tool on your belt if you're an engineer. And so I became an engineer. And after I got my engineering degree, those business guys are the devil, because all they care about is money. They don't care about the pure science, creating cool stuff. And after a couple of years as an engineer, I realized, hey, you can't make that cool stuff unless there's money. I went and joined Team Devil and got an MBA. But I remember for sure that those guys in government were the devil. And now I'm in IPC and I spend time working with the government trying to figure out how, so they won't mess up the industry as well. So I'm always just going the wrong places, apparently. But everybody has to work together is really the message I want. I never set out to be, oh, I want to run a trade association. I didn't even know what a trade association was. By the way, IPC is a trade association, in case you didn't know what. And what that is a nonprofit group that operates on behalf of something. We operate on behalf of the entire electronics industry across the world. So it's a pretty big job. And these guys and their companies are what make everything that you experience from electronics. Okay? You might sit there and go, well, wait a second. Apple makes this phone. Yeah, sort of. They design it. And then they'll go off to, and they need, you guys did the hand soldering on a printed circuit board, right? Well, that's what TTM does. TTM makes those boards, right? And in the future, somebody like Nano might actually just grow those boards. And Honeywell, similarly, actually, you guys actually do make some of the stuff you make, but you also outsource it. So it's a very complex ecosystem across the entire thing. So you might be aware of the brands that go into electronics, but that's really just maybe 20% of the industry. The rest of it is the entire supply chain that goes into that, okay? So that's why it's important to hear from all this, because there's so many different ways to get involved in electronics. There's chemical ways, there's engineering ways, there's electrical, mechanical. What kind of degree was that? Manufacturing engineering. all of that is available. So thank you for the introductions. Now, first, let me, because I don't know how much time do we have, Charlene? Top of the hour? No, we'll go to the top of the hour. We'll see how it's going. But if you have a question, raise your hand. Otherwise, I'll just keep asking these guys questions and we'll try to stump them. But please raise your hand. Yes. So if you have questions about anything you've seen or heard, I'd love to swing by your table. In fact, I'm going to do that right now. I'm going to see if you have, oh yes. If you're actively eating, just keep your food in your mouth and then you don't have to put your mask on. That's fine too. So anybody have any questions for these guys? Things you'd like to know about a career in electronics or how they did something or why they did it? Oh boy, look at this. Everybody's averting their eyes. Don't look at that guy. You didn't avert your eyes. What's your name?
Andy,
Andy, where are you from?
San Diego.
He's not sure though. Do you see the hands? San Diego? That's all right. So Andy, are you taking any classes in science or engineering?
I'm taking computer science quarter.
All right. So Andy's taking computer science this quarter. Is it easy or hard?
It's okay.
It's okay.
Yeah.
So do you have a good teacher?
Yeah.
Are they here?
No.
Okay, good. So it must be a good teacher. Didn't feel like it. Yeah, excellent. So that's great. So have you programmed anything?
Yeah, on a website. I forgot what it's called though.
Okay, so you programmed a website. All right, so if Andy's developing software skills panel, does he have opportunity to use those skills in the electronics industry? Just pick up a microphone, somebody raise their hand and start talking about how those might happen. Go ahead, Matt.
Yeah, I'll grab the mic first on this. Probably one of the most in-demand careers right now is data science. If you can program, if you can understand data, how it's used, there is no limit to the number of jobs. My wife is actually a high school chemistry teacher back where we live, and it is the #1 area right now, not just from an interest level from the students, but also from the need from industry too. So I mean that's my first answer. Absolutely.
Excellent. Anybody else want to comment? Avi, go ahead.
Nowadays, you can't really separate all the three: mechanics, electronics, software. They go together everywhere. Yeah, that's my 2 cents.
Very good. All right, let's go over to this table over here. Oh, I've got some teachers over here, don't I? They look like, I know at least one, right? So what would you like your student, oh, you have a question? Okay.
I do have a question, and it's for TM. I know that you said that you have internships, and so our students are all 12th graders, and they all go out on internships. Many of the companies only offer internships to college students. Has your company ever decided to or considered offering internships for high school students?
Internships for high school students first. Let's go to TTM.
Yes, so previously to my knowledge, we mainly do cater to college students. Over the summer, we had 2 lovely interns who interned this summer, gained a lot of great skills, worked on 2 great projects. I can't get back to you in terms of high school internships. I'm not aware of any at this time, but definitely when you're in college, look for TTM, yeah.
Anybody else? Internships, comments?
So Andrea in the back there is our representative for the San Diego site, so I'm sure she can answer the question better than I can.
Okay, let's go. We got a new panelist, Andrea. Great question. Here you go.
Hi, everybody. My name is Andrea Schaefer, and I work in human resources. So we do the hiring of all of you, and we do have internships for college graduates. And we are going to start next year an apprenticeship program. So for high schoolers. So yes, look at us.
Very good. All right. And that's Case.
I also say that early in my career, working for a different company, I had a high school intern assigned to me in one of my engineering roles. And I've always been very supportive of education at as young as possible and work experiences. I mentioned earlier with my college degree,
That's
the co-op
right.
program there. And, you know, as a high school student, right, you hadn't had a lot of math and science yet, but one of the things you get from work experience that you're never going to learn in a book is how a factory works, how an organization interacts with each other. how to get things done within a large group of people that all have competing priorities. And that kind of experience is invaluable, and you cannot get it anywhere else besides actually getting seat time in a job like that. So like I mentioned, if you can find ways during your high school or undergraduate education to get job experience, it's going to put you ahead of the rest of the pack when you get out of college and looking to start your career in this industry or any other industry for that matter.
Very good. Thanks, Jason. Let me just ask, do you have something else to add, Christina?
So we, at Honeywell, we don't have internships and co-ops at high school, I don't think. But so one of the things that I did in high school instead of that for additional experiences, we had chapters for Science Olympiad. So we would actually go through and compete and do our robotics teams and stuff like that. So while you don't necessarily get the work experience from it, you can still get some of the learning and processing experience that helps you once you get to college and can get to that internship and co-op level.
All right, so how many of you on the panel actually did internships? Oh, wow, only 2 of you. All right, so we'll go to Matt because I know Jason is passionate about this. Let's start with Matt. Tell me a little bit about your internship experience. Who was it with? When did you do it? And did it help you? Was it a waste of time? Why was it important?
So it is a little bit different in terms of timing from high school. So I did my internship at university. I delayed my graduation for my undergrad by a year. It was absolutely the right thing to do. I saw two routes that it was allowed. There were people that did an internship and didn't like where they went, and that's okay. That tells you, it shows you something that you thought you might like that you don't. My case was I absolutely loved my internship. It was very influential. I spent almost 2 years at 3M, and I was a practicing materials chemist. Some of the first work I did was actually for it. So I'm Canadian. We do so much work for the United States. My first project was actually for the US Navy, and just learned so much. So you're in there learning how to actually do the things that you read about, in chemistry textbooks. But the single biggest thing that I learned actually was from my research supervisor. And, like John was talking about advanced education, I was on the route to go do my PhD in chemical engineering myself. And it was at that point that I realized that I was going to pivot, and I too really enjoyed the business side. And that's what led me to my my career with an engineering degree and a business degree as well. So if you get a chance to do an internship, it's as valuable as your actual education, and from my experience anyway. So I really encourage it.
Yeah, let me echo that before we go to Jason. But so I did an internship with General Electric, and I remember my father telling me they wanted to pay me, and this was back in the day, $10 an hour. Whew, I was like, this is awesome. But this was 1,000 years ago, so that was actually real money then. But he said, you would do this for free, just for the experience, just to be able to put GE on your resume so you can get that job. All right, Jason, your experience.
So my co-op was with Visteon Automotive Systems. They were a division of Ford at the time, Ford Electronics, and they spun off while I was there in the 90s. I did 8 different quarters of work at Visteon, rotating through different positions, which is part of the standard program at GMI. So early on, I was an industrial engineering student, and my first 2 spins were in an IE role. And I really found that it wasn't to my maximum liking. I wasn't enjoying the work as much as I wanted to. So I was able to pivot to a manufacturing engineering change in my major within the same department, which is more of a hands-on kind of engineering position than industrial engineering is. And it suited me much better. So that was the first big thing that co-op gave me, was I learned what I wanted to do within the factory, and I was able to identify that before I got pigeonholed into something I wouldn't enjoy for the rest of my life. And the second most important part of that was that I got to work with working engineers that have been in industry for 10, 20, 30 years in some cases. And some of them were informal mentors to me. In fact, I work with one of them now, 20 years after I last saw him. He's a co-op colleague of mine at the equal level that I am in my current company. But as I watched his engineers work and we worked on projects together, I was able to identify specific electives that would help me benefit my career as I chose my courses throughout my college experience. So I was able to identify things the engineers did at work that I didn't know how to do yet, but I had a 400 level class that would teach me that when I was a senior or a junior that I could pick up. So it helped direct my curriculum to really focus on the things that I enjoyed and classes that I would find to be useful in my career, not just be book learning and be 3 credits towards my degree. So those are the 2 things that really help. And they're very experiential based. It's really about getting the experience and finding out where you fit and then molding yourself to fit into that or finding the path that fits you best. Yeah, and it's better to do that as early as possible because I think we'll all say that myself, Matt, John, we've been around long enough to know that, like I said earlier, I only know how to do one thing anymore. If I didn't like this, I'd be kind of stuck doing this and have to change careers. So it's a good thing I like what I do because that helps it make it easy to go to work every day.
So I actually still trying to figure out what I want to do when I grow up. So I keep changing things all the time. So I hope I know more than one thing to do, or maybe I don't know anything how to do anything, and that's why I keep changing. But so we've talked a little bit about degrees. Let me give just a little bit of an overview. So in the electronics industry, there's various types of opportunities to work in the electronics industry. There are operators in which you guys could literally be doing operator work. You know, instead of internship, you could actually get a certification in your junior year of high school, and you could actually be working in a TTM factory on the line and get some experience actually hands-on learning some of those things. So that doesn't actually require any degree at all, not even a high school degree. Don't tell anybody that. But you just go in and you learn that. So there's operators, then there's technicians. So you gain an experience. Sometimes you'll have an engineering degree for that. Sometimes you won't. You'll just have experience for that. Then there's engineers, management, executives, et cetera. As you go through, there's different types of levels. But so let's go through the panel and just let's talk about what degrees you've received. So do you have what degree did you start with and how far did you go?
So I was in Cubs when I was 7.
Excellent. Wonderful. Were you a bear cub?
I was a
Did
bear
you
cub
make
and
it
I
to
was
bear
a
cub?
scout. And let me
Were you
tell you,
those?
scouts are great because I know like lots of knots still that I use.
So awesome.
I do a lot of outback, so they're very helpful. Degrees. So I have my undergraduate is in chemical engineering, as I mentioned, from McMaster University in Canada. And then I went on to do my MBA. So I have a master's in business as well from Sir Wilfrid Laurier University. And those are my 2 educational degrees. But the one thing that we haven't talked quite a bit about are professional and extended education. So, you know, once you exit the academic school realm, you know, most of us are lifelong learners, and you know, take advantage of a lot of companies that you'll work for. You'll be able to continue on your education, as well as, you know, trade associations like IPC. You can always be taking education moving forward. And so 2 that really come to mind that have served me well and will continue to in the rest of my career. One is I'm deemed a certified systems lead auditor. This was training I received while at IBM, and it allowed me to understand the process from the very beginning to the very end. Again, a kind of a niche thing, but you know, something that really stuck. And then the other one is I continued on with a lot of data analytics and analysis. So I went through the entire program, and I'm also a certified master black belt in statistics. So that sounds pretty boring, doesn't it? But it helps with, you know, my job and was, you know, kind of beyond the academic setting.
Okay, Christina?
So I have an associate's in general studies. My college updated that, like as I graduated with my bachelor's in chemistry, they were like, by the way, you can have an associate's now too.
Bonus.
So I got a bonus degree. But so again, to echo Matt's point, I went more with a certifications route once I got to work, because at work, they're like, you want to do it? Cool, go do it. Here's the money. And so I ended up getting my green belt in design for Six Sigma for statistics and process validations. And then we also have certifying agents in ours. So I went through a lot of certifications for plating and cables and conformal coating and all different types of chemical processing to be able to go out and audit facilities and work with them on some of their other types of processes.
Okay. Chance? We're just moving down the road here.
Yeah, so I went to San Diego State University. What I really liked there was the mix of a great classroom experience as well as hands-on engineering projects. For example, I put a propeller in the wind tunnel and tested its efficiency. So you do a lot of hands-on projects like that, which really helps. Really great to put on your resume coming out of college.
At San Diego State, I got a degree in aerospace engineering as well as a minor in computer science. I know we were talking about earlier how impactful computer science is, and I would heavily recommend studying computer science, at least at some minor level, to get experience with a coding language to put in your resume, because you'll see that in job postings all the time.
Very good. Avi? So Avi, your degrees are from out of this country, so maybe a little different, yes?
That's a problem. I have no college degrees.
Oh, there you go. See, maybe
Yep.
I was wrong. You don't
We're
have
done.
to have a
No, I'm sorry, no. But I have a lot of certification. Like I said, I've been in the Army for 3 years, so I didn't go to school. But while I was in school, I studied basic electronics, which got me to the Army to a nice position as a technician. In the Army, I went through three or four different certification for code. So C#, for example. So they taught me how to program. They taught me how to solder. They taught me how electronic world, how to use all these measurement tools. So I'm more certification based. And when I joined Nano Dimension, they just shoved more knowledge in my face, which is 2D design, which is the wires, how to draw these wires correctly, and 3D design to really do 3D electronics in the end. So certifications really got me through. Having no college degree, I will note that on that side, that maybe it will hurt a bit financially. This is just what I'm gonna say. But for me, it didn't matter. I love what I do. And I can always get by. I know that with my toolkit, with my tool set, I can do well providing for myself and my family.
That's great.
Which is all that's important. So do something fun and make sure that you eat at the end of the day.
Perfect. Jason.
Hi, so I mentioned earlier, I have an undergraduate degree from GMI Engineering Management Institute, now known as Kettering University. It's in manufacturing engineering, which is kind of an uncommon undergraduate degree. Most of those are the graduate level. But the school I went to was very focused on industry. It was founded by General Motors. Very focused on producing engineers with good practical skills that can go out into industry. So they developed a manufacturing engineering undergraduate program, which fit me perfectly. It was very hands-on, very experience-based. We had work experience, very lab-oriented for your last 3 years. Oh, by the way, it's a 5-year program because they're serious about making sure you have a full, wide education on all the engineering topics. Manufacturing engineering is an interesting kind of degree because it's one of those where you have to know a little bit about all the different kinds of engineering. In my factory, I work with electrical engineers that are designing RF circuits, or electrical engineers that are designing power circuits. I work with mechanical engineers. I work with software engineers that are writing code. I work with operators and technicians on part of our team to ensure the operations are working well. I work with the quality engineers who are experts in quality requirements and statistics. I need to be able to speak their language. I'm no expert in electric circuits. In fact, I failed circuits the first time I took it and got a D the second time. So I don't have to be an expert on how it works, but I have to understand what the people around me are telling me so I can figure out what that means for how to make my job experience as good as possible for the company and maximize the value I'm providing to the company. A good example of that is, board doesn't work. I've got to figure out why it didn't work. I don't know how boards work. So I went to electrical engineers and they helped me troubleshoot. It's not because of this area of the board's a problem. Oh, well, here's the defect I found in that area. We're going to rework that. We're going to upgrade the process. We're going to make it better. If I didn't have the ability to interact with those people in that role, I wouldn't be able to help use their information to do my job better. So it's an interesting role, and it's an interesting kind of education because you get a lot of different backgrounds. And then on top of that, over the course of my career, like Matt mentioned, the rest of us up here mentioned, certifications are an important part of evolving your career. As you get out of college and academia, you get into industry, you're going to find there are very niche topics that you may not know enough about or feel like you need to know more about. And there's lots of certifications available from lots of different organizations. I was a master IPC trainer for the certification programs for 4 of the 5 programs for a while. I've been certified by American Society of Quality in 6 Sigma Black Belt, quality engineering, and reliability engineering, things I didn't take in undergraduate that were college level exams to get certified for. And I use those to improve my skill set, to improve my career along the way, to make myself a more valuable employee to the companies I was marketing myself towards when I'm looking for new jobs.
Excellent. Thanks, Jason. So a couple of things I hope you heard as we talked about this. So if you want to continue in the electronics field and you're hoping that school just is about to end here in May, it goes on for your whole life. in the electronics field. We're always trying to learn more because the world's always changing. I mean, how many of you have either a Samsung or an iPhone? Smartphones? Yeah, okay. So 80, when did it come out? No, 94. 1994. Matt had already graduated college by 1994. He never had a smartphone through college. I don't know how he tweeted anybody. But the whole point of what you basically need to develop a love for learning. And it's not a love for just sitting in class and sit back and hoping that the stuff enters your brain. You just need to start thinking about it and say, hey, why does that work? How does that work? I love Avi's story because I actually think Avi is the future. That I think right now, a lot of the education systems are ripe for revamping. So while we all have these degrees, except for Avi who has certifications, I actually think the future will be more focused on certifications. It certainly is after you graduate, but I actually sense that there will be some changes because we have people right now, especially in like the software fields, they don't need the engineering degree. They're able to get Cisco certified or whatever certified and go right in and start working because they've shown they can do the job. So the certification path is really critical for all levels, depending on what you want to do. So it's very, very interesting as well. But anyway, develop a love for learning because to succeed, you need to keep learning. It doesn't stop when you graduate high school. It doesn't stop when you get your bachelor's degree. It doesn't stop when you get your master's. It doesn't stop. I have my doctorate. It doesn't stop when you get your doctorate. I'm still trying to learn things. So you always need to be learning. And it just makes you a more well-rounded and frankly, learn lots of different things because you'll be able to bring things from outside your expertise in and do applicable pieces of this. Can I share a story? You guys okay with that? I did this in my keynote. That's why it's fresh in my brain. So there's this hospital in London, all right? It's a children's hospital. And this was about, I want to say 7 years ago. And they had, it's terrible, but in their ICU units, they had a great mortality rate. They had babies that were dying all the time. And they couldn't fix the problem. They didn't know what to do. Guess who they reached out to? Has anybody heard this story before? You guys know what this is? They reached out to Ferrari. What the heck does Ferrari have to do with a hospital? So have you guys ever seen Formula One races where they do, the pit crew changes? They change the tires and put the gas in, etc. How long does that take? Anybody? Give me an answer. How long does it take, sir? About 1 second. That's right. They change all 4 tires. They gas it up. They clean the windshield. They give the guy a little bit of food or something or drink to go. What else do they do? You know, anybody? Anyway, there's a lot of things going on it's about, I think, 1.4 seconds, something like that. 20 people, zoom, they're done. And it's perfect. So they called Ferrari up and had their Formula One team come and look at the hospital, the ICU unit, and how they were doing surgeries and things like that. And they actually started looking at their processes and how they were lining things up and how they were prepared. And they changed everything based on Ferrari's input to this hospital. And the fatalities dropped through the floor. So the whole point I'm sharing that is because of diversity in your education, in the things you study, in the people you talk with, will help you have better ideas. Just having one single idea and one single perspective is never as successful of having multiple views from all over different disciplines, different people, etc. All right, so keep learning from everywhere you go. All right, we've got one more question. We got a question. Any questions? So I'm being told, hey, yes, thank you. Oh, tell us your name and where you're from.
I'm Kayla, and I'm from San Diego. Oh, I'm from E3 Civic High too. Yeah.
Very good. What's your question?
My question is actually for Christina. As a woman in the STEM field, unfortunately, we know that the STEM field is male dominated. So what were some adversities you had to overcome? And what advice would you have for younger girls looking for a career in engineering?
Great question. Christina, represent all women in the industry.
No pressure, no pressure. Okay, so this is a really good question, and I get asked it a lot. And one of the things I say is have confidence in yourself. So I did not choose to go into engineering. I went into chemistry, which was kind of like 50-50, little, you know, the guys were a little bit more prominent, but I was in the engineering department the whole time for all of my other classes because that's where they were. And coming up here into the industry with materials engineering, there are a couple girls. I think we have like 5 in our department of 20 or so, which is kind of exciting. But one of those things is you have to be confident in yourself and take charge because, you know, sometimes it is hard, you know, especially because when you start off young. So I came in at 22 and I walked in and they were like, how old are you? And I was like 22 and they're like, cool. My youngest is 27. And I was like, that's great. And I became a lab work director within my first 4 months of working. And so then I had to tell a 66-year-old what to do. And if I needed something done in the lab, I had to be like, hey, person who's been around like 3 times my lifespan, you know, please do this. And it's challenging sometimes, but one of the things that was so important is being able to ask questions, but also recognize that sometimes you have to assert yourself. You know, even if, you know, you don't always know the answer, it's okay to be like, I don't know, let me go get the answer. Take charge, take the action, and take the initiative for yourself. Because I tell you what, it's not going to be a guy that is like, you know what, you'll be good at this. Go do that. You know, that was so my intro into engineering was another female engineer. I was like, you should try this. And I told her, I was like, I do not understand why you're suggesting me. I have a chemistry degree. Like, I don't do all that kind of stuff. And she was like, you could problem solve and you don't have to take crap from people, you know? And she's like, that is all you need and you'll be perfectly fine. And really, and I had wonderful mentors, you know, so finding the people as, you know, as soon as you get to where you are, you know, making friends, or sometimes finding, you know, the one guy that seems to be the loudest person in the room and get to know them and learn some of their struggles. And if you make those networking connections right off the bat, you know, that really helps to be able to be seen with the people the guys respect, and but also see that, you know, that you also can command the same level of respect, and showing that you earned your place there is really important.
Excellent. Thank you, Christina. Let me just share one thing. It's been changing because our industry is becoming more and more diverse, I will say. So in the years that I've been coming here, so when I was in engineering school, I think there were 2 female engineering students out of 1,000. Okay, so not very many at all. And now here we are. So we had an EMS summit. So if you think about the electronic supply chain, you've got the brands that design the stuff typically. Then you have, it starts with the chemicals and the raw materials. They create a board, and then on the board we put the stuff. We call that the EMS industry, the guys that put the stuff on, the assembly industry, often it's referred to as well. So we had a summit, for a leadership summit for the EMS industry on Monday, all day Monday. 1/3 of all of the leadership that came to that was female. So it's changing in a very positive way. So great question. Oh, I can do 2 more. You said 1 more last time. Boy, I tell you. Other questions? Anyone out there? You don't want to know, nothing to know here. Was the food any good? All right, excellent. We had good food. Did you guys get to go on the show floor at all? Did you see anything that was interesting or that you'd never seen before? If you saw something different, raise your hand. You'd never seen. If you thought it was cool, keep your hand up. All right. If you thought you'd like to learn more about it, keep your hand up. All right. I got kind of hand up here. So the guy in the black sweatshirt, I'm going to run back to you. And while I'm running back to you, I just want you to tell me what you saw. This is not a hard question. What did you see? That's what I'm going to ask you. Everybody's like, I thought I was getting out of class today. People are calling on me. All right, what did you see?
I don't know the exact name, but like I think the computer oven where the boards go through the real process of
putting parts
yeah,
on.
yeah, like the
So it was an oven. This is probably the biggest oven you've ever seen, right? How big was this oven?
big,
Like, just guess in feet.
like
The people online didn't get to see it, so I'm trying to describe it for them.
okay, I would say like 10 feet long or so.
10 feet long. I would guess it was probably 20 feet long. Can I get 40? No, I would say, sorry, yeah. All right, so gigantic oven. So here's an oven that's nearly 20 feet long. It's probably 15, something like that. And did they tell you how hot it was getting in the oven? Okay, so how hot does an oven get? And
Yeah, 300 C is a good upper end.
300 degrees Celsius. That's pretty hot. Water boils at 100 degrees Celsius. So we get to boil it 3 times over.
I like to tell people that, have you ever been to Quiznos and seen the oven they use to toast the sandwiches? That's just a really small version of those ovens we use to melt the solder. Except it's a lot longer and ours get a lot hotter.
Yeah, so basically, yeah, it's the conveyor belt. Yeah, you got a question? Yes. Gold star here, asking a question, and up there, the 2 people actually wanted to ask a question. Here you go.
Oh, is there any bigger like oven?
Are there any bigger ovens than 15 to 20 feet? Anybody?
Yes.
Well, not just yes. Tell us about it.
So I think we have one on one of our processing lines that's about 30 feet long or so, but it has so we also have SMT lines where they also have, different oven phases. And so it's not just one thing that is the oven. I know you can probably do this better than I can. But so with our reflow processes, they have to go through different various temperature phases and all that stuff. And a lot of them are long conveyor belts, but it was about 30 feet long or so for one of them that I've seen.
Cool.
I worked with one oven that was curing a coating we were applying to the circuit boards. And because we didn't have the space on the line to have a long linear oven, we actually purchased what we called a vertical oven. So this was a vertical carousel oven that was probably about 15, 20 feet long and about 40 feet tall. And it went into different shelves, up to the top, across the top, and back down again. So they're very creative in how they apply heat to circuit boards and fitting it into the space that you need in a lot of different ways.
So I'm going to ask 2 more questions to the audience because I just thought of them. First, how many feel like about every 4th word that's being said up here is a foreign language that you don't know what it means? That's okay. Even Charlene says, I don't know what that is. What's a conformal coating? I don't know. What's SMT mean? We got to work on our panel here because we gear our conversation to the audience. But so these are things you'll learn about, just details about the industry. One other one that I wanted to go to. So you said you had a black belt and you have a green belt. How many think this has to do with karate? Yeah, exactly. Definitely karate. It doesn't, right? It's not karate. What is it? What the heck is this black belt and green belt that you guys got?
Well, according to my daughter, it's this belt right here.
Your
She
black
said, Dad,
belt.
you already have a black belt. It's right there.
Yeah, exactly.
So the best way to describe it is I would kind of describe it as swimming lessons. That comes to mind. There's different levels that you go to swim, right? If you're kind of learning how to swim to, you're getting close to becoming a lifeguard. It's the same idea. You learn things in an introductory way. It's all math based, and you just kind of graduate to the next level. It's just a different way of grading. As you go through programs like that, there's obviously different levels of responsibility and kind of scope of what you need to kind of be responsible
So
for.
it's how good you are at using systems to understand quality. Is that
Exactly. Yeah, it's a way to really.
How many understood the
digest.
words that I said? Excellent. 1. Great. That's all we were looking for. Very good. All right. I just thought so we're gonna conclude this panel, and then we're going to shift to the case-sponsored individual work groups, because you have some emerging engineers sitting at many of your tables that you'll continue some discussions here locally. Thank you for your sponsorship case on that. And with that, thank you, everybody. Thank you online for joining us. We are so happy that you could be part of that as well. Good job. Thank you to all our panelists.